Okay, we're going to do some crazy problems that we haven't done in a while. We'll try to do all these most difficult ones first and then let you guys work on some of the others on your own. All right, let's do number 2. I think we may have done one like number 2 before, but it's been a really long time. All right, consecutive integer problems. We did these way back with solving equations. So this was like first semester stuff. So we got 3 consecutive positive integers. So I'm going to let x be my first integer. So what would the second one be? It'd be x plus 1. Technically, you can do minus 1 as well. And then x plus 2. So this would be our second integer and our third integer. Okay, now there were some of these that we did where they weren't too bad. It was just like talking about the sum. This is not one of those. This is one of those difficult ones. So we got to read what it's saying. What is the smallest of 3 consecutive positive integers if the product, what's product mean to do? Multiply, so we're multiplying here. Of the smaller 2 integers, so that would be x times x plus 1. All right, so the smaller 2 are x and x plus 1. We're going to multiply those together. Is, what does is tell us to write? Equals. And then 5 less than 5 times the largest integer. Okay, so 5 less than is a minus 5, but it needs to be over here on the end. And then 5 times the largest integer is 5 times x plus 2. Okay there. So, read through carefully, set it up. Now, this is not easy to solve. What do we need to do? Any ideas? What should we do? Okay, we want to solve for x. To do that, we're going to need to distribute. What do we get when we distribute right here? X squared plus x. And over here, we'll get 5x plus 10 minus 5. Oh, gracious. I can put 10 and 5 together. Let me just do that. Okay. How do I solve this?
You can move the x or the x squared is over to, like you subtract it over to where the 5x is.
Like this.
Yeah. And then you'll have x squared minus 1.
Okay. What do I do now? I could. I probably would not move x squared because this is a quadratic. Like, I'm not going to be able to just solve for x right here because if I try to, like, square root both sides, then I still have an x in my answer, right? So, when you have a quadratic, when you have an x squared and you have another x, you need to move everything to one side and factor. Okay, that's the only way we really know how to solve quadratics. So I would move stuff over here. I would do x squared minus 4x minus 5 equals 0. So we got x squared minus 4x minus 5 equals 0. Then how do we factor that? We'll have an x and an x, and we're saying minus 5 plus 1. Do you guys agree? That'll give you the negative 4 in the middle. Okay, you're not done. What have you got to do next? Equal those to 0. So x minus 5 equals 0, so that'll be x equals 5. And then x plus 1 equals 0, so x equals negative 1. I've got 2 answers. How do I know which one to pick? It's not going to be the smallest. We do want the smaller of the 2 integers. But these are my two possibilities for my first integer. What does it tell us right here about the consecutive integers? They are positive, right? So I either, what this is telling me is I either have -1, 0, and 1, or I've got 5, 6, 7. So, because this is just the smallest integer, so I'm not going to use this one. I'm going to use 5 instead. And it wants to know the smallest integer, so it's 5. Right there. Okay, questions? That is a difficult question. I do think you're going to see, maybe not that, I do think you may see something like that, but I don't think you'll see tons of those. Maybe one. I think 3 is harder. The larger leg of a right triangle is 3 centimeters longer than its smaller leg. The hypotenuse is 6 centimeters longer than the smaller leg. How many centimeters long is the smaller leg? So we're talking about a right triangle here. And we know one of the legs is shorter than the other. So, notice it says right here, the larger leg of the right triangle. Larger leg of the right triangle, that's this side right here. Is 3 centimeters longer than the smaller leg's right here. Then we've got the hypotenuse right here is 6 centimeters longer than the smaller leg. So both of these are talking about their relationship to the smaller leg. We don't know what any of the sides are, but I'm going to call the smaller leg right here, I'm going to call it X. Since I don't know what it is. So if this is X, what can I label the longer leg here? X plus 3. Very good. What could I label the hypotenuse? X plus 6. Okay. Alright, so does that make sense so far? Alright. What can I do now? Does it tell me about like a perimeter or an area? No. There are problems like that where maybe we would use that information, like add them all together and set equal to perimeter, or find the area and set equal. It doesn't give us either one of those. What's the only thing we really know about this triangle? It's a right triangle. What can we use for all right triangles? We have a 90-degree angle. That's true. And what can we do with the lengths of the sides for all 90-degree triangles? What? Well, say it anyway. Nobody else knows. Huh? Pythagorean theorem is exactly right. Don't be afraid. So you got to do Pythagorean theorem with this. Look at how crazy this gets. I love this problem. It is so great. This was created to torture young minds. An evil genius came up with this question. So, a squared plus b squared equals c squared. Now, how to solve that? I can't do anything while I've got like these squares right here. So I've got to think x plus 3 squared is x plus 3 times x plus 3, right? So I could distribute, I'd have x times x would give me x squared plus 3x plus 3x plus 9. So that is x squared plus 6x plus 9. So this is going to be x squared plus 6x plus 9. I'm going to do the same thing over here for the x plus 6. So x plus 6 squared is x plus 6 times x plus 6. So you got x squared plus 6x plus 6x plus 36. So x squared plus 12x plus 36. So x squared plus 12x plus 36. Let's see if I can zoom in a little bit there. Is that a little better? Yeah. Okay, how do I solve this? It's going to be a quadratic because we've got an x squared, right? So with quadratics, we always want to move everything to one side and try to factor if we can. So I could subtract the x squared. I'm just going to subtract one of these x squareds on each side, which will get rid of one of them, or you could combine them first and then subtract one. I'm going to subtract my 12x right here and subtract my 36 right here. So I will have x squared minus 6x minus 27 equals 0. Okay, so for this, I can factor. Now, anybody know how that one factors? Plus 3 minus 9, positive 3 times negative 9 gives me negative 27, and then 3 plus negative 9, that gives me negative 6. That'll work. And then we'll set each one of those equal to 0. So x plus 3 equals 0, and x minus 9 equals 0. So x equals negative 3, or x equals 9. And now we guys even see what they're asking us for. How many centimeters long is the smaller leg? Would it make sense to have a negative value for a length of the side here? It would not, so you're going to throw that one out. 9 is going to be your answer. Okay, questions on that? That one's pretty crazy. This is one of those, like, it's a question on the test to see who really, really, really knows their stuff. Yeah, if it's not you, don't worry about it. You can still do really well without getting that question right. But there'll be some that are like this. All right, let's see. Let's look at 5. 5 is not calculator active. Can't use your calculator on 5. All right, so tell me something. Tell me something I can eliminate or throw out. Any ideas? There are lots of ways to approach this one. Whenever we're looking at graphs, particularly of parabolas, there are several things we can look at. We can look at whether it's a happy face or a sad face. We can look at the y-intercept. We can look at the x-intercepts. We could try to find maybe the vertex. Or we could just plug in points. Let me show you like one of my favorite things to do for a problem like this. Let's just plug in 1. F of 1. Okay? So that would be 2 times 1 plus 3 times 1 minus 2. So 2 plus 3 is going to give us 5. 1 minus 2 is negative 1. So I get negative 5. What this tells you is you plugged in 1 for the x and you got out negative 5 as your y. So the point 1, negative 5 should be on the graph. Okay, which one is it on? B, and only B, so B is your answer. I could have plugged in other numbers. I could have plugged in 0. I could have plugged in like 10, but 10 wouldn't be a good number to plug in because it's not going to be on the graph, right? You can see like these are not very wide parabolas. So that's just one way you could do this. You could plug in, if you plug in 0, that's going to find your y-intercept. This is set up. The x-intercepts of this, if you set this equal to 0, are going to be at x equals 2, and then you'll have 2x plus 3 equals 0. So you got 2x equals negative 3. So x equals negative 3 halves, which is negative 1.5. So you should have x-intercepts at negative 1.5 and positive 2. This one also has those same x-intercepts, though, so you want to be careful with that. All right, let's see. Let's do 6. Floor of a rectangular cage has a length 4 greater than its width. So let's draw a rectangle. So length, width. James increases both dimensions by 2, which equation represents the new area of the floor. So this side is the width. It tells us that the length is 4 feet greater than the width. So length is like the width plus 4. Right? So if I erase this side right here would be W plus 4. Okay, but he doesn't just do that. What does he do after we set that up? What does James do? Okay, so that's going to add 2 to both sides here, right? So now we would have a rectangle, a bigger rectangle. This side would be W plus 2. This side would be W plus 6. And they are asking us to represent the area. How do we find area of a rectangle? Length times width. So for this one, it's going to be W plus 2 times W plus 6. That's not an option. What could we do to this to make it match one of those options? How do I multiply it? It's the opposite of factoring. We're distributing here. Yeah. So W times W will be W squared. This will be plus 6W. This will be plus 2W. This will be plus 12. So W squared plus 8W plus 12. And that is D. When you get to 9, you're going to start using your calculator. So everything before 9 is non-calculator. Once you get to 9, you're going to start using the calculator, which will make some of these much easier. There's still a few that are a little bit tricky. So I'm going to turn you guys loose to work on this. I need you guys working very hard for the last part of class here. We'll see how far you guys get. I may decide to take off a few of these if you are working really hard. So go ahead and work on those. You may work with somebody if you would like. A lot of you are alone because of our absences. So